Today, we repair to customer battery packs, 12V, drill batteries. He said they didn't last long and became unreliable quickly. They were idle until he saw our video and asked for repair and upgrade. Issues: won't charge or discharge. Never held charge well. Full charge lasted approximately 20 minutes, then die. Label shows exaggerated specs. 12 volts, 6,200 milliamp hours. It says high power, long lasting. If so, why repair it? It must be overrated. Many use these for work or home, but overrated specs and failures are common. We'll open it to see the cells. Two identical packs. Disassembling these can be tricky. Some have internal screws, which you remove. Others, like this, have clips to carefully release. Let's pick one. To open, use a flathead screwdriver. Start from this side or other, your preference. This one is easy to open. 16.8 volts clip-ons are harder, not easy to disassemble. Clip here was broken. Wouldn't stay on tool, causing it to fall and lose connection. Tool worked intermittently. Be careful with force. No brute strength. Open. See? It's all clips, especially this side. If not careful, break clips. Then it wobbles mounted, causing poor contact. Tool worked on and off. All this dust. Broken a while. Label peeling off. Inside, red cells. These red cells. These red ones. Cells are these red ones. Not matching power lithium, 620 mAh. High power, long lasting, completely different, right? Other pack same probably. Open to check. See? Those who know batteries see approximately 800 to 900 milliamp hours after use. Maybe 600 to 700 milliamp hours. Actual capacity, 700 milliamp hours. Expected, poor cell quality. Got it. Start on 1. 4 cells, using imported LG. To 50 mAh each. Config 3S1P, these packs common. For home or workshop. Capacity often exaggerated. Actual capacity overstated. Circuit board removed. Padding foam. For 12 volts home drills, poor battery quality is frustrating when needed. Without it, small tasks become difficult. Need it, but unreliable. Worst, annoying. Open now. Cells inside. Many end up with this type. Some different color. Install new cells. Placing cells. Correct orientation. Secure them. Connecting. Start from top, not bottom. If top connections misalign with board holes, adjust by rotating cells. Old nickel strips removed. Connect new ones. Top connected. Install circuit board. Align holes properly. Solder top first. To secure. Prevents board moving. During process, apply flux and solder. Compare old and new. See here, soldered properly. Original was like this. And here. Slapped on, touching MOSFET. If connected to next pin. Short circuit. Cutting corners. Could be trimmed. Soldered neatly, didn't bother. So not only sells low quality, dild also. Sloppy. That's it. Connect bottom. All soldered. Test voltage. Before, after board. To check function. Input 11.07 volts. Output 11.07 volts. Board functions normally. Use load tester. Check discharge. Test it. Watch. Start discharge. Shows current. Power. Normal. Good cells last. After discharge test. Charge it. Steps important. For reliability, plug-in charger. Power on. 12.6 volts charger. See if charges. Use power meter. Monitor charging. Look. Charging light on. Tower meter approximately 13 volts. Unplug. Drops to 0. Plug back. See, charges normally. Testing is responsible. Can't just assemble and ship without ensuring function. Wastes their time. Frustrates, especially far. Do our best. Test sterilely. Not doubting skills. Avoid mistakes. Dead or safe. Some need urgently. If arrives faulty. Untested. Dig problem. Secure wires properly. Like this. Back into casing. Clip broken. Affects attachment. Found used. COMPATIBLE casing works better. No wobble. Good contact. Use what we have to function well. Snap closed. Battery fixed. Test with tool. Sound. Power now. Good battery improves efficiency and usage time. Right? This one done. Other pack same. Do later. If similar battery issues, and DIY skills. Try repair yourself. Thanks customer for trust. Video end. Thanks for watching. See you.